Let's take a look at this phrase. 3 times the sum of 26 and 4. So, we've got a little bit more going on in this phrase. 3 times the sum of 26 and 4. Let's take it one piece at a time. 3 times something. So I know that I'm just going to write 3 times. Well, 3 times what? The sum of 26 and 4. Remember, that was a common phrase that we had up top there. So the sum of 26 and 4, I know, would be written 26 plus 4. But that needs to go in parentheses, okay? Because we want 3 times this amount. So the numerical expression that goes with this phrase is 3 times, parentheses, 26 plus 4. Take a look at this one. 6 times the difference of 60 and 51. 6 times the difference of 60 and 51. So the difference of 60 and 51, I know that I'm subtracting. So the difference of 60 and 51 looks like that. And I want 6 times that amount. 6 times 60 minus 51. I wonder, and even in the problem before, let's go back to this one. I wonder if I wrote this 26 plus 4, the sum of 26 and 4, and then I put the multiplication on this side. Would that make a difference? 3 times the sum of 26 and 4. Think about that for a second. It would not make a difference because I have to solve what is in parentheses first. We learned that last year with the order of operations. 26 plus 4 is 30, and 3 times 30 is 90. Look at this expression. 26 plus 4, I would solve that first, and that equals 30. And 30 times 3 is 90. Those expressions are equivalent. They are the same. They are equal. The same goes for this phrase, 6 times the difference of 60 and 51. I can write 60 minus 51 first in parentheses and then times 6. And you will get the same exact value. So 60 minus 51 is 9. And 6 times 9 is 54. 60 minus 51 is 9. And 9 times 6 is 54. So those two are exactly the same. I want to take a look at another one. Take a look at this phrase. The sum of two 12s and 4 3s. The sum of two 12s and 4 3s. So the sum of tells me that I'm going to add something. Okay? The sum of this and this. I am going to add these two together. So now I need to write them as expressions. So what would two 12s look like? Remember, that's 12 plus 12, which is the same thing as 2 times 12. Put that in parentheses. And what would 4 3s look like? 3 plus 3 plus 3 plus 3. Or 4 times 3. Remember that we are trying to find the sum of. So my addition sign goes in the middle. That is what this expression, this phrase would look like as a numerical expression. Could I find the value of that? Absolutely. So could I solve it? Yes. 2 times 12 is 24. 4 times 3 is 12. And 24 plus 12 equals 36. Okay? So for your work today, you are going to be taking phrases and turning them into expressions. Oh, there's one more I want to show you. There's one more. Sorry about that. One more. Let's do the sum. The sum of 3 and 8 doubled. The sum of 3 and 8 doubled. So let's find the sum of 3 and 8. How would I write that as a numerical expression? I know I'm going to be adding. So 3 plus 8 is my expression, but then I want that entire sum to be doubled. So I am multiplying it by 2. It's easy as that. So in the next slide, you are going to be doing some more matching.